Welcome, everyone. I'm Tracy Fitzpatrick, and I'll be your moderator today. Thank you so much for joining us here at Netcom Learning, a market leader in promoting lifelong learning, training, and talent development solutions. We are very excited to host today's event, AWS Discovery Day, Machine Learning Basics. Presenting today's topic is Philip Govinda. Philip is a dynamic IT instructor with over 8 years of experience, specializing in artificial intelligence and IT certifications. He is certified in AI Plus Executive, AI Plus Everyone, AI Plus Prompt Engineering, and AI Plus Developer, and delivers practical hands-on training that helps professionals apply AI tools effectively. Philip also has deep expertise in Cisco, CompTIA, and Microsoft certifications. Known for his engaging style and ability to simplify complex concepts, he makes learning accessible and impactful for audiences at all levels. Please bear in mind that this is an overview of a very robust topic. We offer a collection of technical and business courses that can be tailored to your specific requirements. If you are interested in a further discussion, you can make an appointment with our learning consultants through our website at netcomlearning.com. Today's session is also being recorded, so you'll get free access to the recording in the next 24 hours via email. Netcom Learning helps customers build innovative learning organizations by achieving a smarter workforce, adapting to change, and driving growth. We do this with a broad catalog of offerings, developing customized learning plans, and our global delivery capabilities. Since 1998, we have been empowering organizations with our managed learning services to help them reach optimal performance results and address challenges. We do have 9 practice areas in which we specialize. They encompass people, process, and technology training. Today's presentation is from the Data and AI practice area. Netcom Learning offers a comprehensive training portfolio of courses for the topic being covered today. Our upcoming classes include various trainings on the given courses. You can also access a variety of marketing assets, such as the free training and blogs, by clicking on the available event handout. These offerings can be found with a simple search on our website at netcomlearning.com. Welcome to AWS Discovery Day, Machine Learning Basics. We're very excited to have you join this dynamic and informative session. Whether you're a business leader, IT team lead, or a future data scientist, today you'll gain valuable practical insights into how machine learning can drive innovation and transform business outcomes. Led by our expert instructor, this session will demystify key ML concepts, explore real-world applications, and set the stage for your AI journey. Now I would like to give you a quick overview of the logistics before we get started. To begin with, you do have the option to view in full screen by clicking on the full screen button on the right side of the GoToWebinar viewer. Simply hit the escape key to exit the full screen. Everyone has been muted except for our presenters. Feel free to submit any questions you have for the presenters here in the questions pane, and we will address them at the end of the session. And to get the best out of today's events, we've included the slides, courses we talk about, and marketing assets in the handout section of your GoToWebinar viewer. You may refer to them at any time to get a better understanding of today's topic. And we do realize that some of you may have to leave early and want to let you know that as you do leave the session today, you will be presented with a short survey. We would like to request for you to take a quick moment to participate in that survey. Your feedback really helps us understand your learning experience and improve our future sessions for you. The survey answers are measured on a scale of 1 to 5, 5 representing outstanding and 1 representing poor. And now I'd like to pass this over to our trainer to present today's topic. Hey, Philip, thank you so much for joining us today.
Okay, thank you, Tracy. Hey, welcome everyone to today's webinar. We're going to be covering AWS Discovery Day, Machine Learning Basics. My name is Philip Govinda, and I'll be your instructor for the session today. And this session is going to be designed to introduce you to fundamental concepts of machine learning and how AWS supports this growing field with practical tools and services. So whether you're completely new to machine learning or just looking to reinforce your knowledge, it's going to be the right place for you. And my goal here is to simply show you what AWS can do, what machine learning can do, and just feel like it could feel like a complex subject and help you understand how machine learning can be applied in these real-world scenarios. So by the end of the session today, you'll have a more clear picture of what machine learning is, how it works, and the different ways businesses are using this to innovate and grow their products. Now, this is Discovery Day, so our emphasis will be on concepts. We'll look at some use cases and the high-level pipeline. So no coding or advanced math today, just basics, foundational knowledge. And we'll also look at how AWS supports machine learning with services, tools, and a structured pipeline that can help you move from an idea to a production model. So thank you all for joining today, and we're going to dive right into machine learning and how it can help you out in your day-to-day work. So looking at the agenda for today, what we're going to be covering. First, we're going to start off with an overview of machine learning fundamentals. So we'll just define what machine learning is and explain how it fits into a broader context of artificial intelligence. And we'll discuss all the key benefits. Next, we're going to walk through the machine learning pipeline. And this includes each step of the machine learning lifecycle from data collection all the way through model deployment. Okay, then after that, we're going to explore real-world applications of machine learning. So we're going to highlight examples of how businesses across various industries are actually using machine learning to solve problems and create value. Okay, after that, we're going to provide an overview of AWS machine learning services. So you'll learn how AWS makes machine learning accessible by offering all of our managed services. We'll look at some integrated tools and scalable infrastructure. Okay, and then finally, after all that, we're going to cover some key takeaways, and then we'll close the session with a live Q&A. This will give you guys a chance to ask any questions you might have, discuss topics in a bit more detail, just to give you guys a better idea of what's going on here. So first things first, we're going to start off with the basics and talk about what machine learning actually is. Great. So starting off here, we have machine learning, and machine learning is a subset of artificial intelligence or AI. And when we look at artificial intelligence, it's a very broad field that focuses on creating systems capable of mimicking human intelligence. And this includes tasks such as understanding language, recognizing images, with solving problems, and just making decisions altogether. Now, machine learning falls under this umbrella and refers specifically to the ability of a system to learn from data and make predictions or decisions based on the data that you feed it. Okay, so how it works is the more you input, the better the output's going to be. It's going to build a database over time. Now, machine learning also systems to learn from data. It allows all your systems to learn from data. So instead of relying on a fixed set of instructions or rules, machine learning systems use algorithms to analyze data, identify different patterns, and they're going to adapt over time. So this makes them highly flexible and capable of improving as they're exposed to more information. So the more you get, the more you feed it, the better your answers are going to be over time. So for instance, a recommendation engine on, let's say, a shopping website learns your preferences by analyzing all of your browsing history and your purchasing behavior. It's going to look at that history, and it's going to give you a better output tailored to what you're searching. Hey, next one we have here, machine learning improves performance without being explicitly programmed. So this means that once a model is trained, it can generalize its learning to new unseen data. And take the example of, let's say, a spam filter. Developers don't need to write individual rules for every spam message. Instead, the model learns from a data set of labeled messages and detects spam based on the learned characteristics. And there are going to be three key benefits here of using machine learning. First, it helps in automating repetitive tasks. Let's say tasks like classifying emails or sorting images. Tasks that would take us a lot of time is just very repetitive, not hard, just repetitive. It can do it automatically for us in seconds. Second, it provides better accuracy over time as it learns new data. Okay, so again, like we said, the more we put into it, the more data we build into its base, it's going to give us better answers over time. Hey, and third, it allows businesses to make data-driven decisions very quickly, enhancing customer experience and operational efficiency. So common applications of machine learning are going to include things like speech recognition, where you have fraud detection, product recommendations, as well as predictive maintenance in industry settings. Okay, and it's going to be increasingly used in healthcare, which we'll see here in just a bit, for diagnosing diseases. Finance industries can use it for managing risks in the company, and then retail for personalizing customer interaction. So again, depending on what industry you work in, it can be used in most cases. Here we have supervised learning, and supervised learning uses labeled data for training. So this means that the data used to train the model includes both input and the correct output. So for example, I said earlier, a spam detection system, the model is trained on a data set where each email is labeled as either spam or not spam. And this algorithm, this allows the algorithm to learn the relationship between the input features and the desired output. So over time, it's building things and to recognize when something's spam and when something's not spam. Hey, it's going to be most commonly used for classification and regression problems. So classification first. Classification is when we want the model to assign data into categories such as identifying whether a transaction is fraudulent or legitimate. Where regression now is when we want the model to predict a continuous value, like forecasting the price of a house based on square footage and location. Both of these types of problems require labeled data to train the model effectively. Okay, so we're going to look at both classification as well as regression moving forward in terms of input data. Hey, a couple examples of supervised learning. We said we looked at spam detection, and we said price prediction. So, like we said, in spam detection, emails are going to be analyzed based on text features and metadata to determine if they belong in the spam folder. And in price prediction here, a model might learn to predict the price of a product based on features like brand, demand, or the season that we're in. Okay, and supervised learning models are often trained using algorithms like linear regression, decision trees. We have random forests as well as and also will support vector machines. So the key strength of supervised learning is its ability to provide very highly accurate data and high quality data when available. However, one challenge is that creating labeled data sets can be very time consuming and costly, especially when expert knowledge is needed to label that data correctly. Okay, so despite this, supervised learning remains still one of the most widely used forms of machine learning in the business field, as well as academic applications due to its precision, and it's it gives us very clear meaning to it. So supervised learning, it's going to be a lot to build on, but once the input and database is built, we're going to get very accurate answers. Hey. So moving on now, on the other hand, we have unsupervised learning, and unsupervised learning uses data that does not include any labeled outputs. So in other words, the model is not given any predefined categories or correct answers, and the algorithm has to identify pattern structures or relationships on its own. Okay, so unlike supervised learning where we had someone there, we now have unsupervised learning, and this is the one that will not create any patterns on its own. So this model works by analyzing the inherent structures of data. So what it's doing here, it's going to try to find similarities, differences, and groupings without any human intervention. Okay, and this approach is helpful when we don't know what we're looking for ahead of time. And a couple examples of unsupervised learning include customer segmentation or anomaly detection, looking for anything that's off within our network. It can do that for us. Okay, so when we look at customer segmentation, a business can group customers based on their purchasing behavior, things like demographics or preferences, without knowing those groups beforehand. And this helps marketing teams develop strategies for different customer types. So again, unsupervised learning, there's no human intervention. We kind of just let the system run and build a database on its own. In anomaly detection here, the model learns what's normal, or it learns what normal data looks like, and then it starts to flag data when unusual patterns come up. And this is commonly used for fraud detection and network security, where we're detecting rare suspicious activity. Very important. So it can track things like when customers log in at, or when employees log in at unusual times, if they're downloading things more frequently. It just it detects when things are changing in the network when they move away from the normal baseline. So any anomalies will be detected. Hey, we also have some popular algorithms that are used for supervised learning. We have k-means clustering, we have hierarchical clustering, and we also have principal component analysis, PCA. Now, these methods are used across many industries, from we said healthcare to finance, just to uncover any insights that might be harder to find manually. So that while unsupervised learning is very powerful, it can also be more complex to evaluate because there's no right or wrong answer to compare it against. Okay, we're just getting an answer, there's no human intervention, and we have nothing to compare it to, there's no data set to compare it to. So that's why visualization tools and metrics here, they're important in helping us interpret the results that we're getting. Okay, so again, supervised learning, we look for human intervention there. We have a data set to compare it to. Unsupervised learning, there's no human intervention, and there's no data set to compare it to. Right. So next one we have here, class, is going to be our reinforcement learning. And reinforcement learning is a type of machine learning where an agent learns through rewards and penalties. So rather than being given labeled data or supervised data, the agent learns by interacting with an environment. And it receives feedback in the form of positive rewards for correct actions and negative consequences for the wrong ones. Okay, and this learning process is often compared to how humans learn from experience. So, a couple examples, just like a child learning to walk or a dog learning a new trick, the agent tries different actions and adjusts its behavior based on what worked and what didn't work. Okay, so this one here will actually adjust based on positive data, and it will also adjust on negative outputs as well. So reinforcement learning is commonly used in game AI as well as robotics. So for example, reinforcement learning algorithms have been used to teach AI to play games like chess, for example. We will see it for a lot of video games as well. And it also helps robotics learn complex tasks like walking, grasping objects, as well as navigating through a room. So again, it learns by interacting with the environment. It learns from mistakes, and it learns from its positive moves as well. Okay, and a key characteristic of reinforcement learning is that it focuses on sequential decision making. And the agent doesn't just make one decision, it learns and it must learn to make a series of decisions that maximize the total reward over time. And this makes reinforcement learning ideal for environments where current actions affect future outcomes. And a couple common techniques include Q learning, we have policy gradients, as well as deep reinforcement learning. And these methods require significant computing power and are often combined with neural networks to handle complex environments. So, in summary, here, reinforcement learning is about learning from interaction. Okay, so the agent becomes smarter over time by exploring its environment, receiving feedback, and improving its decisions accordingly. So again, this one here will learn over time. It's going to learn from interaction, and it's going to learn from its mistakes, and over time, it's going to become a smarter version of itself. Right. So next one we have in class is going to be deep learning. And deep learning here is a specialized type of machine learning that uses neural networks, like we just covered, with many layers. And these layers are modeled after the structure of the human brain, allowing the system to process a large amount of data to make more complex decisions. Now, the deep in deep learning refers to the multiple layers of processing between the input and output. So each layer extracts increasingly abstract features from the raw data input. For example, in imaging processing, early layers might detect edges, while deeper layers identify objects like faces or cars. Okay, and Deep learning is capable of handling very large and unstructured data sets, and this includes data types like images, video, audio, and natural language, things that traditional algorithms struggle to interpret. Hey, and because of this, deep learning has become essential in fields that require complex pattern recognition. Now, one of the most common applications of deep learning is going to be image recognition. So, for example, facial recognition software uses deep learning to identify people in photos and videos. And it's also used in self-driving cars to detect objects like pedestrians, traffic signs, road lanes, things like that. Okay, and we also see voice recognition as well as another area where deep learning really shines. So we have virtual assistants like Alexa, Siri, Google Assistant. They all use deep learning to understand spoken commands and respond accurately. Hey, and a couple popular frameworks of deep learning include TensorFlow, we have PyTorch, also Keras. These tools are going to allow developers to build and train deep networks for a wide range of businesses and different scientific applications. So really, in summary here, deep learning is more so a backbone for modern AI applications that rely on a complex, high volume of data. So next here, let's talk about the machine learning pipeline, which outlines the major steps required to build and deploy a machine learning model. Okay, and each stage is going to play a very critical role in creating reliable, accurate, and useful predictions. So first there, we're going to begin with data collection, and this is the process of gathering data from various sources such as databases, sensors, user interactions, as well as public data sets. And the quality and quantity of this data is going to be crucial because your model can only learn from what it's given. If the data is biased, incomplete, or inaccurate, the model's performance is going to suffer. So step one is always going to be data collection. Next is going to be data cleaning and preparation. So raw data usually contains noise, missing values, or irrelevant features. So this step involves removing duplicates, filling in missing values, converting formats, and scaling features altogether. So we can also split the data set into training, validation, and test sets to ensure that the model can generalize well here. So after we collect the data, we're then going to clean it and prepare the data. After preparation, we're going to move to model training. So here we're going to use the training data to teach the model how to find patterns and relationships. And the model is going to adjust its internal parameters to minimize errors and improve accuracy based on this data. So now after the data is cleaned and prepared, we're now going into model training. Then comes model evaluation, and this step uses the validation or test set to assess how well the model performs. And we're going to use metrics like accuracy, precision, recall, or F1 score, depending on the type of problem that we're working with. Okay, and if performance is not satisfactory, we may go back to tune all the parameters or try different algorithms. So now we're going to evaluate the outcome here, and we're going to test how well the model is performing. Hey, and finally here we have deployment, and this is where the model also, this is where the train model is integrated into the production environment, like an app or a website or internal system. So it now takes in real-world data and provides predictions that support business or user decisions. And once deployed, models must be monitored to drift performance drops and retain needs if as needed. Okay, so this entire pipeline here is very iterative, meaning that you can return to the earlier stages if new data is collected or better performance is needed. And managing this workflow effectively, that's a key in success, in being successful in the machine learning projects. Okay, so it's going through it again. We're just going to start off collecting the data. Once everything's collected and gathered, we're then going to clean it, prepare the data, go into model training, do some evaluation, test how well it's performing. Finally, once the tests are done, we can now deploy it into the field so we can put it into the production environment. Okay, class, let's take a quick 5-minute break and then I'll start the remaining topics after the break.
Sure, we are now going to take a 5-minute break, but before we do that, we are going to launch a quick poll that we want to invite you to participate in. Doing so helps us know how we can better serve you by telling us who might be interested in more information or in taking some additional training. In addition, we have a lot more informative webinars coming up, so please go to netcomlearning.com/webinars in order to register.
Great. Welcome back, everyone. Let's continue from where we left off on our lessons here.
Okay, great. So just getting into each one of these steps here a bit more in depthly. So we said the first step in machine learning pipeline, we're going to start off with data collection. And this stage is all about gathering the information that you will train your model. So we're going to collect both structured and unstructured data. So structured data refers to the data that is organized and formatted, like rows in a spreadsheet or records in a database. And this includes fields such as dates, names, sales numbers, or even sensor readings. Where unstructured data, on the other hand, does not follow a predefined format. Okay, and the examples include images, audio files, videos, social media posts, customer reviews. Even though unstructured data is harder to process, it's going to be incredibly valuable in machine learning. And some common data sources include databases, which store all transactional or relational data. Okay, sensors such as IoT devices, they can generate real-time environmental or mechanical data. And we also have APIs, also referred to as your application programming interfaces, which allow us to pull in the data from external services or platforms. Okay, and another huge source is going to be user-generated data, which includes interactions on websites or apps such as clicks, searches, or purchases. And it's important to collect data that's relevant, high quality, and representative of the problem you're trying to solve. If the data is biased or incomplete, your machine learning model will reflect those weaknesses. Okay, and lastly, always make sure your data collection process respects privacy laws as well as ethical standards. Because again, the last thing we want is to be held liable or at financial risk for breaking the law. So this includes things like getting proper consent or ensuring secure data handling, especially when dealing with personal or sensitive information. So again, data collection, we can get it from structured data, unstructured data. We have sensors, APIs, as well as user-generated data, all things that we can collect. Perfect. So next one we have here, guys, is going to be our data preparation. So like you said, after the data is collected, the next step will be data cleaning and preparation. Yeah, and this step is crucial because your model's performance depends heavily on the quality of the data it's trained on. So the first task is cleaning missing or incorrect data. And real-world data is very rarely perfect. It often contains errors, missing values, or outliers. For example, a temperature reading might be missing, or a name might be entered as not available. And you can fix these issues by removing any invalid entries, filling in missing values, or replacing them with averages or medians. So we're going to look at here normalization and features. So normalization first. Normalization means scaling your numeric data so that all the values fall within a common range, usually between 0 and 1. And this helps ensure that features with large numerical ranges don't dominate features with smaller ranges when training the model. You're also going to apply feature engineering during this step, and this involves transforming existing data into more useful features or creating new features that make patterns in data more visible to the model. So, for instance, you might combine date and time into a single timestamp feature or extract customers' age from their birth date. Hey, finally, it's important to split your data set into training and task sets. So typically about 70 to 80% of the data is going to be used to train the model, and the remaining 20 to 30% is going to be used to test how well the model performs. And this helps you evaluate the model's accuracy and avoid overfitting, which occurs when the model memorizes the training data but does not generalize well to new inputs. So without, again, careful data preparation here, even the most advanced machine learning algorithms are going to struggle. So always treat this step with the same importance as the model training itself. Okay, so again, we started with data gathering, and now we have to prepare the data so that the machine is ready for it. Okay, so once data is prepared here, we have model training at step 3. Hey, and model training is a process where we feed the prepared data into an algorithm, allowing it to learn patterns and relationships within that data. So think of the algorithm like a student. It studies the data and learns how to make predictions based on it. And the better the data quality and quantity, the better the learning process will be. So during training, we also adjust different parameters to improve accuracy. And these parameters, known as hyperparameters, can control things like how quickly the model learns, how complex the model is, or how it handles any errors. And tuning these parameters correctly can have a big impact on how well the model itself performs. So, for example, if you're building a decision tree, one parameter might control how deep the tree can grow, too shallow, and it won't capture enough patterns if it's too shallow. Okay, if it's too deep, on the other hand, it may overfit the training data, meaning it memorizes rather than generalizes. And in this stage here, developers commonly use popular machine learning tools and libraries like skit-learn or TensorFlow. And these libraries are going to provide pre-built algorithms, training functions, and utilities to make the process more efficient and scalable. So to summarize here, model training is where the real learning happens. It's the phase that transforms the data set into a predictive system, and your model becomes smarter and more accurate the more effective your training process is. Okay, so we collected the data, we tuned it, and now we have model training. So once the model has been trained, the next critical step is going to be model evaluation. And this phase is where we measure the model's performance to determine how well it's learned the data from what we collected and gathered and trained, and how accurately it can make predictions on new unseen data. So we do this by using a set of performance metrics that provide insight into different aspects of model behavior. And some of the most common metrics used in machine learning evaluation are going to be accuracy, precision, and recall. So looking at accuracy first, this measures the percentage of correct predictions out of all the predictions. And it's useful when the data is balanced across different classes. So again, how accurate is our data? Okay, next one is going to be precision. Precision tells us how many of the items the model has identified. Okay, and sorry, how many of the predictions the model has identified as positive, and are they actually positive? So how precise is this model? Okay, so again, we looked at accuracy. That's going to be more sort of a balance of classes. Precision tells us how many positives outcomes are actually positive. And this is going to be especially useful in cases where a lot of false positives are costly, such as in spam filtering. Then we have recall. Recall identifies how many of the actual positive items in the model was able to correctly identify. And this one's going to be helpful in situations where missing a positive is more serious than flagging a false positive. So, medical diagnostics, for example. So again, recall, like we said, it's going to indicate how many of the actual positive items in the model was able to correctly identify. Okay, next one we have F1 score. And this is a harmonic mean of precision and recall. And it provides a single metric that balances both false positives and false negatives, making it ideal when we need to consider both precision and recall together. So, in summary, model evaluation helps you verify that the model isn't just memorization or memorizing the training data, but really generalizing and performing well on all of your unseen cases. And these metrics are going to help guide us in deciding whether or not we need to retain, tweak, or move forward to deployment. Okay, so think of model evaluation as more of a testing phase. We're seeing whether we're performing correctly, if we need any changes, if we need to make any tweaks. If not, we can then move forward to the deployment phase. So again, model evaluation is really just a test phase. Okay, and with that being said, we're now going to move into model deployment. And this is going to be the final step, as we said. So deployment is the process of integrating the model into a real-world environment where it can make predictions on on new live data. And this can involve embedding the model into a website, application, mobile device, or internal business systems. And once deployed, the model becomes an active component of a larger system, helping to automate decisions, enhance customer experience, or improve operational efficiency. Okay, but however, deployment is not the end of the process, and it's important to continually monitor the model's performance after we deploy it, because over time data may change, a phenomenon known as data drift, and this can cause a model's prediction to become less accurate. So to handle this, we track key performance metrics in production and retain the model as needed. Some organizations set up automated systems to retain models periodically using new data. So in summary here, deployment brings the model's value to life, but long-term success depends on continuous monitor and improvement. So think of deployment not as the finish line, but as the beginning of an ongoing model lifecycle management. So again, once we deploy it, we still have to monitor it, we still have to watch it just to make sure it's working properly and correctly. Because again, it's one thing to deploy it, but if it's not working correctly, we want to be able to troubleshoot on that, and we want to be able to maintain it and test it even after we deploy it. Perfect. So next we have we're going to look at some real world application in terms of marketing. So one common application is customer segmentation using clustering. And this falls under that unsupervised learning category where the algorithm uses customers based on similar characteristics like purchasing behavior, demographics, browsing history. And these segments allow companies to tailor their marketing strategies, make a lot of promotions more effectively. And again, when we look at marketing, one of the key metrics is always going to be customer segmentation. So we're going to look at things like their purchasing behavior, the demographics, as well as things like browsing history. What are they searching up? And we're going to give them outputs tailored to what's personalized to them. Okay, so with that being said, another powerful use case is personalized recommendations. So we've all seen this with platforms like Amazon or Netflix, where the system learns your preferences or suggests products or content that's just for you. So depending on what show you're watching on Netflix, you're going to get a recommended suggestion list based on the show that you're watching. Depending on what you purchase on Amazon, you may get a recommendation list that are similar to the products you just purchased. So this is usually based on a combination of filtering and user behavior modeling, enhancing the customer experience and increasing sales. So just recommending things that the customer likes to see, likes to purchase, uh, just to give them a more personalized, tailored view of things. Then there's going to be churn predictive, which is identifying customers who are more likely to leave a service or stop buying. Okay, and using historical data, machine learning models can flag early warning signs like reduced usage or negative sentiment in support tickets, allowing companies to take proactive measures here to retain those customers that have a negative feedback. Okay, so again, these examples here, they're going to demonstrate how machine learning adds value by making data more actionable, helping businesses understand their customers a bit better. We have optimized operations and just improved decision making overall. Okay. Then we also have finance, for example, in terms of the real world. And one critical use case is going to be fraud detection using anomaly detection. And like we said earlier, machine learning models are trained on normal transaction patterns, so they can identify unusual activities in real time. So, like an unexpected overseas purchase or multiple withdrawals in a short span, this allows institutions to flag suspicious transactions and prevent fraud proactively. So again, if anything unusual is being done, like for example, we've probably seen it before. If we live in New York and all of our purchases are made in New York, but we travel to Japan, our credit card company is going to flag those purchases that we're trying to make overseas because it's our location changed. Okay, so that's why we have to call our bank to make those changes ahead of time. Another major use is going to be algorithmic trading. And here, machine learning models are going to process massive volumes of financial data to identify trends and make and make trades automatically based on predictive signals. And these systems, they can operate a lot faster than human traders, taking advantage of minor price movements and optimizing their portfolio performance. So it can be very, very good for stock trading as well. Lastly, we have credit scoring models. So instead of relying only on traditional credit scores, machine learning models can evaluate a broader set of data, such as payment history, income trends, and even behavioral data to assess creditworthiness more accurately. Okay, and this subset here can increase the approval of loan rates while reducing default risks here. So again, together, these use cases show how machine learning can enhance security, drive smarter investments, as well as support better lending decisions when it comes to the loan industry. Okay. And next over here, we have the healthcare industry. So when we want to use machine learning in healthcare, so first thing we have is going to be medical image analysis using deep learning. Now, machine learning models, particularly deep learning algorithms, are being trained on massive data sets of X-rays, MRIs, as well as CT scans. And they can identify patterns and detect any abnormalities, such as tumors or fractures, with accuracy that rivals or even surpasses human radiologists. So again, it goes a bit deeper here. The model can make predictions of when things are off, when things are unstructured, and it can even work a bit faster than human radiologists can. Another use case is going to be predictive diagnostics. So by analyzing patient data, including medical histories, lab results, or even generic information, machine learning models can predict the likelihood of developing certain conditions. And this allows for earlier intervention and better patient outcomes if these things are discovered early, if these treatments are if these uncertainties are discovered early in the early stages. Now, the third use case is going to be personalized treatment plans. So, machine learning helps doctors tailor treatments based on a patient's individual characteristics, including lifestyle, genetics, and treatment response. And this moves healthcare from a one-size-fits-all model to a customized data-driven approach that improves effectiveness and reduces side effects. So, in all, machine learning is doing is enabling healthcare providers to diagnose faster, treat more effectively, as well as improve quality of life for the patients. So again, it really can speed up plans. It can detect abnormalities in the early stages, and it lets us act on things a lot faster than maybe a human might notice. Okay. And we also have here some of the benefits of machine learning. So when we talk about the key benefits of machine learning here in a business context, the first benefit is going to be informed decision making. And machine learning models analyze large amounts of data to uncover trends, correlations, and even anomalies, so things that are off. And this empowers leaders and teams to make this data-driven decisions with more confidence and more accuracy. Next, we have improved customer experience. So machine learning can power recommendation systems. It can do personalized marketing. It can even work with responsive chat boxes for online websites. And these tools help businesses engage customers more effectively by predicting their needs and preferences. Now, the third benefit here is going to be operational efficiency. Okay, and machine learning automates repetitive tasks and optimizes workflows across departments. And this results in reduced costs, faster processes, and fewer manual errors. Right? And finally, here, machine learning develops a strong competitive advantage, for example. Okay, organizations that adopt machine learning early can innovate faster, they can adapt to market trends and just stay ahead of their competition. And really they're going to gain insights others might miss. And they'll create new value from existing data. So altogether, these benefits explain why machine learning is being adopted across multiple industries, from retail and finance to healthcare, as well as manufacturing. Almost every industry, if not every industry, can benefit from machine learning built into their systems. Great. So closing off here, class, a couple key takeaways of what we covered from the session. First, we looked at the difference between supervised, unsupervised, and reinforcement learning. And these are three main learning types in machine learning. So you said supervised learning uses labeled data, unsupervised learning finds patterns in unlabeled data, and reinforcement learning trains agents through rewards and penalties. Then, of course, we explored deep learning as a specialized and powerful machine learning approach. And a couple of things with that, we saw deep learning uses neural networks to process massive data sets and solve complex tasks such as image recognition and natural language processing. After we looked at we looked at deep learning, next we examined the end-to-end machine learning pipeline. And we saw the pipeline includes steps from data collection to data cleaning, model training, model evaluation, and finally deployment into the production field. So when we talk about the pipeline is going to be very crucial for building real-world machine learning solutions. And finally, we discussed the business value of machine learning across different industries. So we saw how machine learning can be worked within the retail industry, finance. We we looked at healthcare, and we looked at manufacturing, and of course many more. So like we said, this stuff can be used in almost every industry possible. And again, it's going to support smarter decisions, more personalized experiences, and operational improvements as needed. So these takeaways, they're going to provide a very strong foundation for us in our journey into getting into machine learning. Okay, so with that being said here, I'm going to open the floor now if you guys want to have any questions, do a live Q&A session. So you guys can just throw any questions in the chat, and I'll look them over here now.
Thank you, Philip. That was very informative. And now I'd like to give the presentation rights over to Remy, our vendor manager, to introduce our promotions and webinar-related courses.
Thank you, Tracy. I believe everyone must have learned something new today or would have been able to brush up their skills around the fundamentals of AWS Cloud. I would quickly like to take you through some of our hand-picked resources, which we think will immensely help in accelerating your AWS Cloud scaling journey. Well, this document here of sharing on my screen, this has been shared with you all in the handout section of GoToWebinar panel. You can download this document and access all the resources and browse all the offerings we have curated for you. So first up here is the list of our recommended courses, which we feel will best suit your learning journey after attending our masterclass. All these courses are hyperlinked. Feel free to go through them post-event and check out the course descriptions, prerequisites, and the value it can add to you and your team's skill sets. Additionally, we have curated a blend of resources, including our upcoming and on-demand events, as well as informative and educational blogs. You can make the most of these resources to gain extensive knowledge on the AWS topics they cover. Next up, I am thrilled to introduce the AWS Skill Builder, a dynamic learning center featuring over 600 digital courses crafted by AWS experts. I'm sure most of you must be aware of AWS Skill Builder. What is unique about this platform are the engaging game-based learning experiences. So through AWS Cloud Quest and team-based competitions on AWS Jam events. If you're hearing these terms, Cloud Quest and Jam events for the first time, I would highly recommend you click on this button and you go to our AWS Skill Builder page. I'm sure you will be amazed to see what all the Skill Builder has to offer. They have set of these gaming experiences in practical real world scenarios, which makes it so easy to understand concepts, technology, and processes. And it makes it so interesting for the learner. And for organizations, it saves a lot of time on employee skilling and ultimately enhancing the efficiency and productivity. As someone at Netcom who values continuous learning, I'm confident that AWS Skill Builder will be a game changer for any organization looking to upskill their workforce on AWS technologies. I encourage you to explore the diverse range of digital courses and experiences it offers. You can simply, as I said, click on this button right here, learn more, and you can explore more about the Skill Builder and the pricing aspect of this. Moving on to the next offering. Our free AWS e-learning courses follow a self-paced training model wherein you get the liberty of accessing extensive course-related videos that are delivered by the AWS subject matter experts on the go. So these videos cover the availability on the device of your choice. So you can access them from your laptop, your tablet, or from your phone as well. There are more than 280 videos covering various AWS topics explained in a very easy to comprehend language. You can simply sign up for free, watch these videos, and make the most out of them. Also here, I would like to inform you that this session is being recorded. So in case you want to refer back to any of the topics that the trainer might have covered in today's session, we will be sharing the recording link with you through emails, and also you can access it here by clicking on this button. So you have to download this handout for that. And then if you want to revisit any topic, you can just simply click on the access recording and you can revisit the session and learn at your own pace. Now, apart from our virtual sessions, you can also catch the relevant updates related to IT and business trainings on our social media handles. So please feel free to follow us on LinkedIn, Twitter, Instagram, and subscribe to our YouTube channel for all the latest updates. Our official pages and channels are linked here on the icons. Finally, if you have any suggestions regarding the topics you would like us to cover in our upcoming webinars and masterclasses, please don't hesitate to send us a direct message, or you can leave a comment on our social media posts, or you can just simply email us at info@netcomlearning.com. We would definitely try to come up with the sessions on your suggested topics. Thank you once again for joining us today. Over to you, Tracy.
Thanks so much for guiding us through that information, Remy. And now we're going to go ahead and jump right into our question and answer session. What's the difference between machine learning and traditional programming?
Perfect. So when we look at machine learning versus traditional programming involves explicit instructions, whereas machine learning enables systems to learn from data without being explicitly programmed. So again, when we look at traditional programming, you need instructions there. Machine learning goes ahead without giving it the instructions. It's going to learn from data sets. It's going to learn from working over time.
What are some real-world examples of machine learning in marketing?
Great. So when we look at marketing, machine learning, like we saw earlier in the slides, it's going to look at things like customer segmentation. We have churn prediction, as well as personalized product recommendations. So again, the example I gave was whenever we're on Netflix and we watch a show, after we watch that show, we might get recommendations tailored to the show that we watch. So depending on what genre it was, depending on the cast that was in the show, we might get a similar recommendation depending on what we just watched. Or if we just purchase a product online, we might get recommendations on similar products that we can purchase in the future.
How does deep learning differ from other machine learning methods?
Great. So how does deep learning differ from other machine learning methods? Perfect. So looking at deep learning uses multi-layered neural networks and is especially effective with large complex data sets like images or speech. So when we look at deep learning, deep learning is going to be used for things like image recognition, voice recognition, and just facial recognition in general, just spotting out specific images in pictures or recognizing specific voices.
Why is model evaluation important before deployment?
Very good. So it's one thing to just create the model. It's one thing to just push it out there, but we want to make sure that we evaluate it, we test it before we actually put it into the field. Because again, an evaluation is going to ensure that the model performs well on unseen data and prevents issues like overfitting or poor generalization. So whenever we look at why model evaluation is important before deployment, we want to test things out. We want to make sure it's working perfectly before we push it into the field. And even after deployment, we want to continuously test it just to make sure it's working properly. Because again, after we push it out, we want to monitor how it's working. So again, we want to test it before deployment. We also want to test it after deployment as well.
Once again, I want to remind you that as you leave the session today, you will be presented with a short survey. We would like to request for you to help us by taking a quick moment to participate in that survey. Your feedback really helps us understand your learning experience as we are constantly looking at how we can improve our future sessions. The survey answers are measured on a scale of 1 to 5, 5 representing outstanding and 1 representing poor. We want to thank all of you for joining us today, and if you do come up with any additional questions, feel free to send them to webinar@netcomlearning.com at any time. We hope that you found today's webinar informative, and we look forward to seeing you back here with us soon. Feel free to tell your friends and colleagues about our webinars and other courses. Have a great day, everyone.